Hello everyone, today I'm going to talk about a topic about iris recognition in deep learning, which specifically I will implement a CNN method after a pre-processing step in iris recognition. So first, I'm going to introduce the traditional pipeline for iris recognition. The first traditional step is, of course, the image acquisition. We have to making sure the picture is high quality and the eye with the iris is captured. And we often use near-infrared light to illuminate the eye without causing discomfort. Pre-processing. It is a most important step. We have to localize the iris area. We have to making sure the two concentric circle is located, and we are going to take the outer cycle to get the sclera of the eye and remove the pupil area of the eye. And another step is normalization and transferring the iris region to be fixed, and typically we will making the circular image to become rectangular image, which a better way to compare other image in the future. So which what I mean is, the first step is find the pupil, and the second way is find the scleric area, and the third step is have to noise free the texture with a correct detection. And traditional way of next step is feature extraction. Once the iris is localized and normalized, the next step is to extract the unique feature of every person. It may involve some traditional steps, such as Gabor filter, applying the filter to capture both local and spatial information about the iris pattern, or we can use wavelet transform, using wavelet to analyze the iris texture in different frequency bands, or there's another way is your Fourier transform, analyze the overall iris pattern based on their frequency component. Feature encoding. The extraction feature are then encoded into a compact biometric templates. We can making the every pixel is become 1 and 0, then which can represent as an image in different irises to minimize the variation due to the lighting or environment factors. And the final step is matching. We can making sure the testing iris image have a similarity score to determine the presented iris matches in our database, and making sure the identity is the individual that we are looking for. So in my project, I'm going to use the CNN method to categorize the normalized iris image. So before that, I need to talk about some basic about CNN in image recognition. So CNN recognition, we can find a specific deep learning neural network optimized for the data, such as this kind of a grid-like topology specified to the training of the image, and it can automatically learn important feature from the image, eliminating the need for the manual feature extraction. And some core component of CNN, there are some different layers to train to get those features. One of it is convolutional layers. Apply a filter to extract features like edges, textures, and pooling layers. Reduce data dimensions and computational complexity. And there's a activation function. Introduce non-linear processing. And there is another layer to connect all the pixels in the image based on the learn feature, which is called fully connected layer. So what can we apply the idea of CNN into the steps that I just introduced in the traditional iris recognition pipeline? Convolutional neural network are a very good tool that can apply a lot of steps to enhance the performance and accuracy. Because preprocessing is a step to making sure the quality is good and normalize the region that have a standard format, and if it's possible can correct some angle or shift so that we can have every image have a standardized image. So maybe CNN can use this to reduce the noise, and we can enhance the quality of the image to guessing or average the pixel around the area, correcting the blurriness. And probably CNN can estimate and correct some angle of gaze, normalizing the image. Segmentation, which is locally circular boundary of the pupil and the iris, the outer area. So in this step, we want to accurately detect the circular boundary. So we can train the CNN to detect a circular boundary of the iris and pupil. Probably we can use a pre-trained model. This can be robust against variation in image quality or occlusion and traditional method. And CNN can also be trained to identify the Masek or eyes, lashes, or eyelid, those different things that may or hide or blank the iris. And normalization, maybe CNN can making sure the image is not tilted. We have to be standardized the image. Encoding, in this part, CNN can excel the feature extraction due to their ability to learn the most relevant feature from the training data. And we can directly encoding. Some CNN can design to output binary code or feature vector directly, so that can integrating the feature extraction and encoding into a single step. We also can think about some way to reduce some noise reductions. Matching, CNN can compare feature vector or template derived from the iris or perform classification determine if that match the template in the database, etc. So what I'm going to do is design an iris recognition pipeline that are inspired by Andrej, and I also just following the Daugman and Libor's work. I use their method to localize the polar image, and I use ResNet to stretch the polar images. In Andrew's work, he used a way of stacking the image, and then so that the image will be square, so that it can input to the CNN model and then predict the iris recognition images. So in my way, I was trying to using the first way of Daugman and Libor's work to localize the iris image, and then the second step is to normalize, and the third step is I'm thinking my way of using a stretch polar image, and then finally the fourth step is inputting those collected data from individual into a ResNet residual network. And residual network has a key feature which has a residual block, layer learn residual function with reference to the layer input, simplifying the learning process. And there is a key feature is skip the connections, facilitate the flow of gradient through the network by allowing the output of one layer to feed directly into a later layer, preventing the vanished gradient problem. So, and I will show you the ResNets to recognizing image. You can see that there are lots of layers of filtering as a kernel layers, and then finally you can recognize the minced data sets and recognize the labels. And in this case, I will input the data in the codes. I have processed those images from Daugman and Libor's work. I will use this way as a pre-processing step, and so I get the original image to get the polar image. In this image, the polar image is from the outer area of the eye, so I get the polar area. And the third step is I stretch the area to become a square and input to the ResNet network, residual network, and then it passing to the lots of layers as a kernel filter, which can predict there are testing image. So there are 3 for training, 3 for validate, and 1 image for testing. So each person have 7 image in the data sets. However, there's a lot of challenges in this design of recognizing iris. The primary challenge is data scarcity, because every individual only has 7 image, which is it cannot be very accurate and increase overfitting risk. And probably in the future I can find the ROI focusing on a certain area of stretch image to compare. Maybe there are other way of finding this area so that it will not, because some part of area is affected by the pupil in some part, so probably I will find a middle part of a stretch picture, and then I can find another way to enhance the image, enhance the contrast or a better quality for better model training. And the idea is there are a lot of different CNN model can be applied to training image, and we can design a different pipeline to train a better quality iris recognition system. And thank you.